Hello everyone, welcome to PiSquare Academy. Myself Sekhar. Today I'm going to discuss the interesting aspects of three-phase. The points which I'll be discussing now will be very much familiar to you. I will try to add the flavor of PiSquare for those points. If you are new to the channel and want more such kind of videos, then subscribe to the channel and hit the bell icon to get alerts on new uploads. And our video courses are launched recently and people are enjoying the lectures a lot. They will be useful for any competitive exam. You may check the complete details of the video courses at lectures.pit.in. Links are also given in the description. Come to the topic, that is interesting aspects of three-phase. I'll give you 4 interesting aspects of three-phase. Number 1, what is a phase order? Number 2, what is the importance of phase order? Number 3, 2 important arithmetic operations of three-phase. Number 4, relation between line and phase terms in three-phase. If you are electrical engineer, you have to keep these aspects in your mind all the time. Come to the first one. Let me explain what is a phase order. Phase order, as the name itself says, it is an order in which phases are reaching their maximum values and is also popularly called as phase sequence. So phase sequence basically means it's a phase order. Let me show you the animation for the same topic. For understanding this concept, definitely you have to have a preliminary knowledge on Phasor concept. We have a beautiful video on the Phasor concept. If you watch that video, all your doubts regarding Phasor concept, Phasor diagram will be very much clear. And I have also made a video on why three-phase, why we're not using 4-phase, 5-phase, 6-phase, and why 50 Hz is used in India. You can check all these Y series videos. Links are provided in the description. Give it in the comment how many of you watched the Phasor video already, and also tell me how many of you loved it. Coming back to the phase order, let me open the animation file. Look at this. Phase order or phase sequence means it is the order in which phases are reaching their maximum value. This is the definition. So Phasor diagram for the three-phase signal, what you see here, that's what you have to, if you want to understand this, you have to watch the Phasor concept. Okay. So this Phasor represents this three-phase signal. Look at the Phasor. What is a Phasor? Phasor is a combination of phase plus vector. Okay, phase and vector OR. So you will get Phasor. Okay, that's where Phasor word has come. Basically, it is a vector. It is moving means it has different phases at different times. Anyways, when it is moving, observe the maximum values. First, maximum value is reached by R phase, then Y phase, then B phase. Okay, so R, Y, B. I hope while it is rotating, you have noticed this also, right? This part also you might have noticed. If not, just let me go to quick rewind. So watch it once again. Observe the maximum values. First, maximum value is reached by R phase, then Y phase, then B phase. Okay, I think this time you observed both this one as well as this one, right? I'll not rewind again. If you want, you can go back and rewind and play again. So now tell me the sequence in which they are becoming maximum is R, Y, B. It is continuously rotating. Okay, it is continuously rotating. Then you will get R, Y, B, R, Y, B, R, Y, B. It is also repetitive. Now, if I take reference as R, then the phase sequence will call it as R, Y, B. That's what the phase order. If I take Y as a reference, then Y, B, R, both means the same. If I take B as a reference, B, R, Y, all means the same. Okay, so this entire one, either R, Y, B or Y, B, R or B, R, Y, all means the same phase sequence. Okay, so I like to call this phase sequence as positive phase sequence. This phase sequence is called as positive phase sequence. Let's do another one. Let's try another interesting factor. Look at this. We have now this kind of phasors, again three phasors are there. Now they're rotating. Look at this. First, R is reached to maximum, then B, blue color, then Y, yellow color has reached maximum. Okay. Now the phase sequence is R, B and Y, continuous, it's repetitive, R, B, Y, like this. So you can say RBY or maybe BYR, or you can say YRB. All means just the same. So this is called as negative phase sequence. Okay. Now if I just take both, this is a positive phase sequence and this is negative phase sequence. Maybe you can call positive phase sequence is R by B, this is R by Y, or else maybe this. Yes, true. This all means the same. Okay. Now what is the importance of this phase sequence? Okay. If it is a single phase, for a single phase supply, we have only two, phase and neutral. Right? For three phase, let me take three wire system. So RYB will have three phases, red, yellow and blue. Okay. Now why do we need to focus on the phase order also? Because if the phase order is this positive, then direction of the motor will be in one direction. If it is negative, the moment phase sequence has changed, the direction of the motor will change. So phase sequence or phase order will play a key role in the motor. Okay. Now how this phase order will affect the motor direction? Again, a beautiful animated video is done on the concept of rotating magnetic field concept with beautiful animations with the different phase orders. Everything is done. You can check the links in the description. Okay. Then you will understand how this phase order is going to affect the direction of the motor. So for now, phase order, I can say phase order is important because it will affect the direction of the motor. I think the importance also clear. Phase order concept also clear. Let me go to the next one. What is that? Arithmetic operations. Let me take these phasors. These are the three phasors I'm taking again of equal magnitude, x, they're equal magnitude and displaced by 120 degrees. Okay. So x1 is equal to this, x2 is equal to this, x3 is equal to this. Okay. They are the three functions. This Phasor representation, if you want to write in actual form, these what's its original form. Now let's do some arithmetic operations onto this. Very interesting, guys. x1 plus x2 plus x3. I just want to add these three. Okay, I want to add these three. So I'm not getting into the mathematics of it. I'll give you a complete derivation. Once you add these three, you will get 0. I'm repeating. Once you add these three, you will get 0. These are mathematical derivation of it. Just go through it. Simple mathematics, guys. Okay. These are first point, very important point which you should notice. I'm representing this as x. This x can be anything. X can be voltage, x can be current, x can be flux density, anything, man. Okay. Any variable, flux linkage or anything. It doesn't matter. Okay. So this is what the first arithmetic operation you should know. What's that? If I add all these three vectors at any point of time, you add them, maybe at this position or different position, any position you add them, you will get the resultant as 0. Okay. Let's move to the next arithmetic operation. What's that? x1 minus x2. Now what if I rewrite this? I told you during phasor concepts, right? During phasor concept, I don't like to perform subtraction. I like to perform the addition operation. So I'm rewriting this one as this. x1 plus minus x2. Both means mathematically just the same. Clear? So now x1 vector, this is x1 vector, this is x2 vector. Now I'll have to take the minus x2. This is minus x2. Now this entire angle is 180, or else you can say this entire angle is 180 degrees. This angle is 120. The remaining angle is how much? 60. So that's why it is 60. Now you add minus x2 and x1, you will get a resultant one that is equal to root 3 times of x. Okay. So this resultant one is basically x1 plus minus x2. That is what? x1 minus x2. How I got this resultant as root 3 times of x? Simple parallelogram law concept. Resultant 1, x resultant is equal to this side magnitude is x square plus this side also magnitude is x. Magnitude is x square plus 2 into x into x both the sides, simple parallelogram law, x into x, x square, cos 60. So cos 60 is 1 by 2, 1 by 2, 2 has gone, you will get how much? Root 3x, that's it. This is very important relation, guys, okay, very important relation. So we got now between, if I subtract, if I do this arithmetic operation, you will get how much? Root 3 times of x, okay. Similarly, let me perform x2 minus x3. If I perform x2 minus x3, again you will get root 3 times of x, means what? x2 plus minus x3. This x2 as it is, x3 minus x3 is here, okay, and again 60 degrees. Now tell me, what is this angle, guys? This angle is how much? Total angle is 60, both are having equal in length, so this angle will be 30 degrees, okay, the angle is 30 degrees. Now this one is leading or lagging by this. With reference to this purple one is, it's leading by how many degrees? 30 degrees, that's the second observation, okay. The magnitude as it is, root 3 into x, x is this vector magnitude. Now let's go to the x3 minus x1, again you will get root 3 times of x. So again this is 30 degrees, okay. With reference to this is leading again by 30 degrees, okay. So the conclusion, if I take all points at a time, all these vectors, the resultant vectors, this is x1 minus x2, x2 minus x3, x3 minus x1. All these vectors are having root 3 times of its single phase value, okay. Each phase is having x. The result of, after subtraction, you got it as root 3 times of x, and the resultant one is leading its phase value by 30 degrees. These two are the observations you need to make, okay. Now let's correlate this with our star delta, okay, star delta of line and phase voltage relations, okay, and current relations also. Look at this. This is a delta connection, this is a star connection. This point is clear. Now here in delta also we have 3 phases, in star also we have 3 phases, okay. We connected 3 phases in different 2 manners. What are the manners? In this manner and in this manner. This delta connection is also called as a closed connection. This is called as open connection, okay. Keep this point also, it will be helpful. Now what if you want, if I take individual red voltage, means this is all red color, okay. These voltages, individual phases, each one is having a voltage of V phase, okay, and individual red ones are having a current of I phase, okay. I'm just talking about these red portions, okay. They're having a voltage of V phase and current magnitude of I phase. Here also same, voltage of V phase, current magnitude of I phase. Now I need to perform, let me change the color. Now I want to perform, suppose I want to find voltage between these 2 points. This is one phase, this is another phase. Phase to phase voltage. Here also phase to phase voltage. Here phase to phase voltage, or here phase to phase voltage, we are lazy bugs, right? Instead of calling phase to phase voltage, we will call it as a line voltage. I repeat, instead of calling it as a phase to phase voltage, we will call it as a line voltage. Here also phase to phase voltage, that is called as a line voltage. It is true here also. The next one is similarly currents also. In the line it is flowing, because from these 3 phases we took these 3 lines. Here also from these 3 phases we took these 3 lines. So these currents I am representing as line currents. Inside these red ones, they are called as phase currents with a magnitude of I phase. At these black lines, line currents, we are taking it as IL1, IL2, IL3. Okay. Now tell me, applying just KCL, simple KCL, IL1 is equal to, I can say, same IR is equal to IL1, same IR is equal to IL1, both are same, right? Here also IY is equal to IL1, here also IB is equal to IL3. Means, in case of a star connection, line currents is equal to phase currents. Line currents are equal to phase currents in case of a star connection. In case of a delta connection, see here guys, apply KCL at this point. I want line currents, line current 1. Better I should mention this one as this. Let me write this way: IL1, IL2, IL3. Okay. This IL1, now tell me, apply KCL here, tell me. IR, this is incoming, this is outgoing. This is outgoing. So I can write IL1 as IR minus IY. Similarly here, you will get IY minus IB. Okay. Similarly here, you will get IL3 is equal to, you will get IB minus IR. Here you have a subtraction of two vectors which are displaced 120 degrees. The resultant will be how much? Just now we got it. Root 3 times of individual phase current, how much? I phase. Root 3 I phase. Here also root 3 I phase. Simple. Let's apply the same thing here. For voltages, let's find the voltage. I'm changing the color. Let's find the voltage. No, not blue. I want something different, purple. Yeah. I want voltage now. I'm erasing the currents guys for the sake of clarity. I'm erasing the currents. Now apply. Now let's find the voltage. For finding voltages, KVL will apply. We'll apply KVL. So I want this voltage, this phase to this phase voltage. That is a line voltage. So start here, come back to here, following KVL sign conventions. I told you how to find the voltage for any given network guys. That's the easiest one. Again, links in the description, you can check that. Now this voltage VRY is equal to how much? Plus VR minus VY. Again you have this operation, subtraction operation of two vectors. Again, what is the magnitude here? Root 3 times of each phase is having how much magnitude? V phase. Root 3 times of V phase. That's it. Previously we got the conclusions. We're directly using the conclusions. You don't have to do it now. Okay. The other conclusion is this line voltage will lead the phase voltage by 30 degrees. Magnitude of course root 3 times more, and angle, these line voltages leads corresponding phase voltage, the first one, corresponding first one, this one, VR by 30 degrees. Suppose here we'll get Vy minus Vb. You will get a magnitude of root 3 into V phase, and this line voltage will lead the first term by 30 degrees. That is the second point. Now here, coming to here what will be the line voltage? Here what will be the line voltage? So I'm erasing this stuff. Here we'll get, again start here, same rule, start here, come back to here. VL2 is equal to minus Vy, okay, and L3 is equal to minus Vb. Minus or plus, it's after all AC, right? It's continuous changing. I'm talking about a magnitude now. I'm talking about a magnitude. Both are same. V phase is equal to V line. Here, okay, V phase is equal to V line. The polarity in which you're taking, if I take this as positive, this as negative, then I'll get a positive value also. Okay, so here the polarity we got negative because we took in another way. If you take in this direction, you'll get positive value. So point is V phase is equal to V line. In case of this, V phase is equal to V line by root 3, or V line is equal to root 3 times of V phase, and I line is equal to I phase. I line is equal to, sorry, that's wrong, that's a blunder. I line is equal to root 3 times of I phase. I line is equal to I phase. That's it. I think all these points are clear. What I discussed so far, I discussed what is the phase sequence, why we'll have to go for phase sequence, addition of 3 phase vectors, all 3 vectors, and subtraction of 2 vectors in the 3 phase, okay, and we have related that subtraction concept for star and delta connection to find the line voltages and line currents and phase voltage and phase current relation between phase and line terms. I think these points are clear. As I said, network analysis video courses have already launched, and the complete course is just at 1,900 rupees. You can take that course before the offer expires. Okay, offer is going on. Try to take it. You will get a lot much benefit. You can crack any competitive exam with respect to network analysis. Okay, you can answer any question from network analysis. Okay, if you like the video, hit the like button, share this video with your friends, and do not forget to subscribe to the channel for more such kind of videos. Thank you all.